How's it going? Today we're going to talk about compound inequalities. Compound inequalities are the things like this. We briefly talked about it. We briefly talked about it before, but now we're going to talk about it at length so you understand all the little parts of it. Doot, 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 doot. By the way, if we were taking this and turning it into an interval, we might as well do that now. 3 parentheses, because it's not the equal sign, and then all the way to 5 bracket. And then this one as an interval. So you kind of write them separate, right? So like you've got that. So you've got 3 is greater than infinity. And then we're going to do union because it's an or. Or means that symbol, the U. And then we have x is less than -1, so it'd be negative infinity to -1, but like in a bracket. But this isn't in numerical order, so we're going to have to do a little switcheroo. Switcheroo. We did that one. Okay. We're going to talk about that more at length. Let's do this. Here we go. Ken is driving down the highway and sees the speed limit sign at the right. Explain what the sign means. So the speed limit sign at the right means we have to be between 40 and 70. So explain a car should drive between 40 and 70. But you could drive 70 or you could drive 40 if you wanted. So what are a few speeds that are acceptable to drive? 40, 49, 70, 40.01 works. Anything between those two things. To write an interval that represents that. So like minimum says we have to be greater than or equal to 40. Maximum says we have to be less than or equal to 70. And we can actually be between those two values. Like, so we can write an inequality that's a compound inequality to represent that we're between 40 and 70 inclusive. All right, here we go. How can we use inequalities to describe the set of numbers graphed? So check it out. So this piece means we can everything to the left of -3, which would be less than, okay, -3. And then this one means we want everything to the right of 2 or greater than 2. And we have an or situation. So when it points away, it's typically an or. If we use it in interval notation, it's going to be negative infinity to -3. Ooh, it's a bracket with a U for intersection. Ooh, we're going to delete that now. And we have 2 is greater than infinity. It's exciting. Compound inequality. And here, I'm going to use inequalities to describe the set of numbers graph below. We have another scenario below. We have between this one from here, be that. So we would have x is greater than or equal to -4 on that part. But we also have this part that goes that way, and that says x is less than 1, but we're shaded in between, so it's an and. Or we can write it as one inequality between -4, same symbol, but we're kind of reflecting it, right? X, we're like reflecting this whole thing. And then over on this one, x is less than 1. Now combine those. There we go. Again, write a compound inequality for the graph. By the way, pause it, try to do it on your own, and then unpause it if you want. So here we go. So pause. Good. Now we can just go -2. We have an open circle, so it's going to be a less than x, which is the shaded. And then we want x to be less than or equal to 6 because we have the filled in circle. Compound inequalities are more than one inequality. That one inequality that together. Mr. Suter is loving the sing-songy attitude that was going on right now. My voice is like an angel that is losing their voice. All right, here we go. When we talk about inequalities and we go to solve them, we have this scenario when we say solve the compound inequality. Essentially, what you do is you solve one of them, then you keep the word in between, and then you solve the other one. And you graph them as they're two separate, but on the same line. So this guy, x is greater than 3, we'll graph to that one. X is less than 1, we'll graph to that one. And we work to shade them in together. So we put them on one number line. So x is greater than 3 would be here. And then we have x is less than 1, which would be there. And it's an or. So ors mean like the overlap plus all of the other parts. So this gets a little hairy when we're dealing with situations where like they point the same way or something like that. I'll show you examples of it shortly, but that'll be on the next part of the video. Peace.